Epta Regulatory News Voices. Conversations on the latest trends and regulations in commercial refrigeration. Refrigerant gases are the main pivots on which the dynamics of the Epta group are oriented. It is necessary to do an in-depth study and then a series of observations linked to their characteristics and their specifications to have a broad spectrum, a broad and much more detailed picture. We are making it much clearer today with Francesco Mastrapasqua, Epta Institutional Affairs Manager. Welcome here, I'm Marco Ferraro. Welcome, Francesco.
Good morning, Marco. Good morning, everybody.
So, Francesco, let's start with the first step of ours. The main type of refrigerants available, characteristics and features.
Oh, this is a very interesting question, Marco. It could take long to reply, but let's try to make it short. For us, there are two types of refrigerants, chemical and natural refrigerants. Natural refrigerants are substances that are naturally present in nature, so natural refrigerants don't pose any chemical risk for the environment. And this is the key feature, and I would say the most important thing that we have to consider for our systems. Okay. So we have seen generations of chemical refrigerants passing by because all of them have or had chemical impacts that have been discovered to harm the planet, to pollute, and so we tried to abandon them in the years. I refer to chemical refrigerants that were ozone-depleting substances, the so-called CFC or HCFC refrigerants. They were banned and then they were replaced by others called HFCs. Did not impact on the ozone layer, but lately we discovered that they are potent climate polluters, climate alterers, and therefore they are phased down and phased out by the new F-gas regulation, really because they are potent climate warmers, climate potent greenhouse gases. Okay. So also, this generation of chemical refrigerants is passing by, and now new chemicals are appearing on the market called HFOs or A2L refrigerants. And these new chemical refrigerants have a potential risk being PFAS substances, or, not all of them, but nearly all of them are PFAS or degrade into PFAS and TFA, which means other polluters for the environment. So I think that the age of chemical refrigerants taught us that every generation having impacts on the planet is at risk. So also the new refrigerants are posing a potential risk for the humans, for the environment. And so we think that it could be that it's not the right way to go. Our way to go is natural refrigerants, and mostly we use propane for self-contained units, meaning plug-in systems, semi-plug-in, integral cabinets, monoblock units for cold rooms, and we use CO2 for centralized systems with power rack and cabinets. These are the only two types that we use of refrigerants that we use since several years, and we see that our clients like them a lot. First of all, because they are cheap. Second, because they are not limited by any European present or future regulation, environmental regulation, and at the same time they are super efficient. So this is something that impacts on the energy bill, and so better to be efficient and sustainable than ever. So I think this is our way, and I can see that all around us it's the way of the commercial refrigeration industry.
Francesco, before you mentioned the climate, okay, about it, I would like to introduce another protagonist of our conversation, the GWP, global warming potential.
You really want to go technical today. What is the GWP? GWP stands for Global Warming Potential, and this tells the global warming potential of each refrigerant, and then allows us to scale them in the climate warmers or less climate warmers, if I may say. The definition is the climate impact of 1 kilo of any refrigerant compared to CO2, which has the lowest climate impact among all the refrigerants we could use in refrigeration. So if we say that GWP of one example, R448 or 449, stands in the area of 1,300, 1,400 GWP, this tells us that 1 kilo of these chemical refrigerants has a warming effect equivalent to 1.4 tons of CO2. So why we use CO2 to cut CO2 globally? Because CO2 as a refrigerant has a warming potential that is 1,000 times less than any other refrigerant used before. So this is the gift we do to the environment. And the GWP is extremely important also because the F-gas regulation, you know that we have an F-gas regulation in force, a new one starting from March this year, that allows the use of F-gases just below a limit of GWP. So filters the refrigerants that we can use for our systems in terms of GWP, because globally the F-gas regulation wants to control, phase down, and finally eliminate by 2050 the use of HFCs from the market. We are going to be in Europe, will be the first continent in the world to phase out HFCs completely, zero. And to do so, the F-gas regulation introduces a phase down, so a trajectory of reduction that translates into limitations for the availability of these refrigerants that is extremely sharp these years until 2030. We have to cut HFCs today to 2030 by 6-7 times. All HFCs used by all industries. And this tells us that already by 2030, or even before that, we won't be able to find HFCs anymore in the market. And we see already today a huge price increase of these refrigerants, which tells us that these refrigerants are not economically convenient and are not sustainable because they are going to disappear. So the GWP is an extremely important measure of how impactful is a refrigerant as far as global warming is concerned. And let me mention CO2 as GWP 1, propane as a GWP of 3, or according to the latest 6th version of these values is 0.0 and something, so it's less than 1, compared to chemical refrigerants used for a long time recently, 1,000, 2,000 and so on. And therefore, I would say when you replace a system using HFCs with another one using CO2, you are cutting the direct greenhouse emissions by 1,000 times, which is a lot, which is really a lot. And we believe this is the real way forward for our industry.
Francesco, what future stage will have concerning the transition to natural refrigerants?
Well, I can see that all the business sectors, all the industries are trying to have this process, to start this process of phasing down the use of HFCs and fluorinated gases in general. I can see this happening a lot in air conditioning, in heat pumps, in fire extinguishers, in medical devices. All sectors using F-gases are little by little phasing them out. And this is of course, required by the F-gas regulation, but it is also an environmental commitment of companies. And therefore, we see this happening worldwide and not only in Europe, of course. I can mention that also the US have a kind of F-gas transposition called AMACT that is also challenging F-gases and HFCs, determining their phase out in the next years. Then we have the Montreal Protocol and the Kigali Amendment that commits nearly all countries in the world, with very, very few exceptions, to phase down and out greenhouse gas emissions in general and F-gases in particular. And therefore, I can see this, there is a motion, there is a wave that is in progress that is encouraging a shift of all technologies to natural refrigerants.
Okay. So what about the flammable, mildly flammable, high-pressure refrigerants?
Well, you know, every refrigerant operates under some conditions that require the know-how to use it. When we handle flammable refrigerants, we use flammable refrigerants, we use propane. But we use it in very, very small amounts according to the safety technical standards in force in Europe and worldwide. So we use less than 150 grams of propane, so the same safety standards type as household fridges, for instance, so in absolutely safe conditions. By the way, these technical standards have increased the possible charge of refrigeration circuits to 500 grams from 150 grams, telling us that it is safe to use propane until 50 grams charge per circuit. So we use propane in a very, very safe environment and with safe solutions. Mm-hmm. At the same time, of course, we can't say the same for mildly flammable refrigerants when used to do stores, supermarkets, because in this case, using a flammable refrigerant poses other types of risks. Why? Because generally a supermarket requires charges like 50, 100, 200, 300, 400 kilos of refrigerant within. And using several hundred kilos of refrigerant in a store where refrigerant circulates also in the public area of the store poses some safety risks. And therefore, the standards in place today for these mildly flammable refrigerants require a lot of attentions. So first of all, to certify the system against flammability risk, the risk of a potential start a fire, you know, that can occur in case of leakages of refrigerant that may accumulate in some areas of the store and determine a dangerous situation. And at the same time, you know, managing and servicing an installation with flammable refrigerants require you technicians to have special skills. They have to be trained to do so and use special tools, special devices, specially designed and realized to make service and maintenance to these kind of refrigerants. Mm-hmm. And several other, let's say, limitations. I would say the most important limitation, these refrigerants can only be used in small amounts. So the charge is limited by the safety standards. So limiting the charge means immediately limiting the capacity of the cooling machine that we can do. Mm-hmm. So using maximum 50 or 70 kilos of a mildly flammable refrigerant gives us the possibility to do maximum 30, 40 kilowatts of cooling per circuit. And this is, I would say, insufficient for our normal requirements, which are much above 30, 40 kilowatts in most of the cases. So we see mildly flammable refrigerants hardly usable or a way forward for supermarkets. Okay. At the same time, you correctly notice, Marco, that also CO2 has the issue of high pressure. But I would say this is not a problem. Why? Because CO2 is a completely technically mature solution. CO2 is used in supermarkets in, let's say, more or less 100,000 stores in Europe. So it's the standard choice of our customers. So pressures have never been a problem for our industry, and we do CO2 systems as company Epta since 25 years. We started in the late 90s to use CO2 for our systems. After 25 years, I think that we've learned all we could learn about CO2, and we can manage it absolutely 150% safely.
Okay, I think now the last step ahead to make together is concerning, Francesco, to the comparison between the consumption and the efficiency of these solutions that you mentioned before. How to proceed?
Well, again, a very interesting question. Efficiency with different refrigerants. This is an issue that, it's a question that in some cases seems really not a correct question, because we don't think that the efficiency of systems depends that much from the refrigerant itself. Sometimes we read about this refrigerant guarantees 50%, 30%, 70% less energy consumption than another refrigerant on the same system. This is impossible, you know. And even the comparison of systems with different refrigerants is something that makes really little sense. I would say to make a fair comparison, you should be able to run a full supermarket, a full store, for 1 year with one refrigerant, and then replace the refrigerant with another one and see the consumptions over 1 year. But when we want to compare chemical refrigerants, F-gases, with other refrigerants which have a totally different, let's say, technical solution like CO2, how can you compare? The same system cannot run with both. So you are obviously comparing two different stores. And when you compare two different stores, they are two different stores. Even if we could do them identical layout, identical power racks and cabinets, they would not be identical anymore, because the building is different, the insulation, the lighting, the air conditioning, the turnover of the store, number of visitors, number of times you open and close doors would be different anywhere. And each of these factors impacts the efficiency a lot, more than what we imagine. So I would say that comparing the efficiency of different refrigerants is a very hard and slippery way to go. So I would stay away from that and I would say that there exist efficient systems, there exist efficient appliances, but efficient refrigerants is like the fuel for cars. Okay. Is the car that is efficient, you know? Mm-hmm. You know what I mean? So that's my point of view.
Okay, so I think that we faced a well-articulated mosaic, didn't we? Okay, but I would like for sure to thank you for your words and your sentences. And I would like to thank the audience following us till this moment, and I invite you to follow for further conversation. Thank you again, Francesco.
Thank you, Marco. Thank you all.
Bye-bye.